In order to calculate the atomic mass, we need to know three things. We need to know how many isotopes there are. We need to know the mass of each one and the percent abundance of each one. So using the table on the right for our example, we have 1, 2, 3, 4, 5 different isotopes. So we have 5 isotopes, and we have the mass and the percent abundance of each one. The equation to now solve for the atomic mass is the mass of the first isotope times the percent of the first isotope plus, maybe I'll write this in blue, plus the mass of the second isotope times the percent of the second plus the mass of the third times the percent of the third plus the mass of the fourth times the percent of the fourth, and finally the mass of the fifth times the percent of the fifth. And notice I wrote everything in the blues. You're adding each term. So you're going to multiply those numbers, and you're going to add those numbers, and you're going to get 5 terms for the 5 isotopes, all divided by 100. What I've now done is I've just multiplied these numbers and inserted them in the red brackets. So here's the multiplication for the first, adding it to the multiplication of the second, adding it to the multiplication of the third, and so on for all 5. You're going to add those all together, get one giant number, and make sure to divide that entire thing by 100, and the final answer is 47.878. You can check to see if you're on the right track if the answer is close to numbers that are in the table. So if we take a look back at the numbers of the masses, you see that these numbers are in the mid-40s, 45, 46, 47, 48, 49. Our number, our final answer, should be somewhere within the range of 45 through 49. And our answer is 47, which is within that range. So it kind of makes sense to what it would be. And notice that third isotope is 73% abundant, so our final answer should be closest to this mass, which it actually is.